Hi everyone. In this section we can study about a problem regarding the journal bearing. It is a fundamental problem. So just listen. A lightly loaded journal bearing has following specifications. Bearing diameter is equal to 880 mm. Bearing length is equal to 60 mm. Then the diametral clearance is 0.12 mm. Journal speed is 24,000 rpm. Radial load is 900 Newton. Absolute viscosity 4 cp. So they are asking about determine the frictional force, torque, coefficient of friction, and power loss. So first of all we can write the given data, that capital D we can write it as 80 mm. Then small letter L, that is equal to 60 mm. Then 2C, that is the clearance, we can write it as 0.12 mm. Then the speed is 24,000 rpm. In the journal section we can convert the rpm into rps. So convert that 24,000 to rps, that will become 400. Then load is given, we can write W is equal to 900. Then Z is given, that is the viscosity, absolute viscosity, that is 4 centipies. We can convert it into Newton second per meter square, that is 4 into 10 raised to minus 3. So these are the data we can directly convert. Capital D for the diameter, bearing diameter. Then what is L, that is for the bearing length. Then C for the clearance. Here diameter clearance is given, so we can take it as 2C. Then speed we can write it as capital N for rpm and small letter n for rps. Then what is the value of W, that is for the load. So then viscosity is for Z. These are the notations used for the journal bearing. First of all we can find the value of frictional force. So take your data book. In page number 351, equation number 15.3b. The shearing force of the on the shaft Fs is equal to 4 pi square r square L Zn into 10 raised to minus 6 by C. Just compare this equation, that is the data book equation, with the textbook equation. Both equations are same, and using this equation we can find the value of frictional force. Here capital D, that is the bearing diameter, is equal to D plus 2C, small letter d plus 2C, that is the bearing diameter. Here bearing diameter capital D is given as 80 and the clearance is given as 0.12 diameter clearance, that is 2C. Now using this equation we can find the value of D, that is equal to 79.88. So just take the value of R from this diameter, half of that D is equal to R. Then all other data are given in the question, so we can calculate the value of force using this equation from our data book. That will become 100.76 Newton. Then second question they are asking about the torque. Torque is also given in the textbook page number 351, equation 15.3c, that is T is equal to Fs into R. Equation is equal to 4 pi square r cube L Zn into 10 raised to minus 6 divided by C. So just compare that equation with our textbook equation, both are same. If we substitute these values, that is the all data are given in the question itself. So substitute all the values in this equation, then we can find the value of torque. That will become 4024.42 Newton millimeter. So this is the torque value. Then next they are asking about the coefficient of friction. Again, from our data book, page number 353, equation number 15.4a, that is the coefficient of friction. F is equal to 2 pi square into 10 raised to minus 6 into Zn divided by P into R by C. So just compare that equation with data book equation with our textbook equation. Both equations are same in final way, and they substitute all the values in this equation. Here, what is the value of P? P is not given, so we can write P is equal to W into W divided by 2RL. So note this equation. P is equal to W into W divided by 2RL. In page number 355, equation number 15.6c, that unit load is given, P. If we substitute the value of W, R and L in this equation, we can find the value of P here. Then if we substitute the value of P, Zn, R and C in this equation, we can find out, or we can calculate the value of coefficient of friction. That value will become 0.1118. Then last they are asking about the power loss. What is the value of power loss? It is also already given in the question. Power loss we can calculate using the equation P is equal to 2 pi nt divided by 10 raised to 6. That is in the equation. In our data book, page number 355, equation 15.6h, that is P is equal to 2 pi divided by 10 raised to 6 into T into N. So if we substitute these values in this equation, then we can find the value of P. That will become 10.11 kilowatt. Okay. Then it is a simple case. Similarly, we can go for the second section also. Second question. I can read it. Just listen. A full journal bearing has the following specification: shaft diameter 45, bearing length 66, clearance ratio 0.0015, speed 2800 rpm, load 800 Newton, absolute viscosity 8.27 into 10 raised to minus 3 Pascal second. Then determine frictional torque, coefficient of friction and power loss. So first of all, we can convert the given data into our notations. Shaft diameter we can denote it as small d, that is given as 45 mm. Then bearing length we denote it as L, that is equal to 66 mm. Then clearance ratio is given, we can write it as C divided by R, that is the clearance ratio, 0.0015. Then we can find the value from this D, so we can calculate the value of C, that will become 0.03375. Then N is given in RPM, convert it into RPS, that will become 46.67. W is given as 800 Newton and Z is given as 8.27 into 10 raised to minus 3. Next we can find the value of torque, frictional force and power. So first of all, we can find the value of torque. That is already given in the question. In that equation is already given in our data book. Torque equation from page number 351, equation number 15.3c. So T is equal to 4 pi square R cube L is Zn dou 10 raised to minus 6 divided by C. So if you substitute all the data in this equation, that is the given data in this equation, we can find the value. Then torque will become 339.41 Newton millimeter. Then coefficient of friction we can find using the equation for 15.4a. What is that equation? F is equal to 2 pi square into 10 raised to minus 6 Zn divided by P into R by C. So, please compare the textbook equation with our data book equation, and all other data are given here. We can find the value using the first equation, or we can find the value using the second equation. It is just comparison, that is T is equal to F into W into R. Before that, we can find the value using the general equation from the data book. Then both will be same, that will become 0.0189. Then next they are asking about the power loss. That will become 0.099 kilowatt. How we can calculate that equation? That is given from the data book, page number 355, equation 15.6h. That is P is equal to 2 pi nt divided by 10 raised to 6. In our data book, that equation is written as 2 pi divided by 10 raised to 6 into Tn. So, if we substitute all the values, all the given values in the question, then we can find the value of power loss. Okay. So, write and calculate this equation in your notebook. Okay, thank you.